Okay, so I'm going to be using this video to explain everything you need to know about the product through, and not product through per se, the dot product of a vector and then the cross product of a vector. Now, remember, we have done this in our previous class, live section, right? So something you don't know before is that the product through and the dot product, they just have something very, very simple in common, right? Very, very simple. So what is that? So your dot product, like I told you, they are, when you're talking about the dot product, right? You can see it like this. Now, everything you need to take note and to put in mind is when you're having I dot I, it should be equal to J dot J. This should be equal to K dot K. And I told you it's going to be 1. But anytime you are having, maybe they're in perpendicular form, I dot K, or you are having K dot I, is the same thing as when you're having J dot K, is the same thing as having K dot J, is the same thing as having J dot I. There's anytime they are like perpendicular in nature, you're going to get 0. And that is why, like I told you before now, if you are given two vectors, let's say vector A, you are given in terms of component I minus 2J, then plus 2K, and then B is given as, let's say you have I plus 3J minus 3K. Then if you're asked to do A dot B, then you're just going to be doing, considering this and this. Every other thing is going to be 0. So I have I dot I here. So I'm going to have 1. But in this case, minus 2 minus I multiplied by 3J, I'm going to get 0. The same thing, I multiplied by 3K, I'm going to get 0, right? So for B, for the next component, which is J, when J dot this particular guy, you're still going to get 0. But J and J, you're going to consider the component there, which is minus 6, right? Then plus, for the K guy, you're still going to get 0. Then lastly, for the K, you're going to get 0 for I, you're going to get 0 for J. Now you consider the K, then this is going to be minus 6. So you can, is it minus 6? Yes. So that's how to get the dot product. But now we are talking about cross product. Cross product now is a different ball game. Cross product is a different ball game. This require your idea of matrices. Now, if you don't know these matrices before, let me know. We'll do it in our live class, or you can watch my previous video and you can get this clearly. And we will do this in the live class also. Now, matrices, the major thing you need to use in solving the cross product of 2 or 3 vectors, all you need to do is to make sure you can do you can compute the determinants of a 3 by 3 matrix. So for instance, if we are given another vector over here, let's name it vector C. Let's put it properly. So let's name this vector vector C. So if you have vector C, which is given as 4i plus 5j, then plus 6k. Now, you can be given a question like, what is A cross B plus C? So this will test your idea and your knowledge on vector addition. And for vector addition, we can do A, we can do B plus C over here together, component-wise. So I have B plus C. B, this is 1 plus 4, this is 5. So B plus C, we are going to get something like 5i. Then for the J component, this and this is 8 plus 8. You have 3 here, and you have 5 of J, right? So lastly, we're going to get for K. K here is minus 3K. Here is plus 6K. So I'm going to have plus 3, right? So to get the determinant of this particular guy, because now we're doing A, which is over here, cross these vectors AB. So we are going to have I here, J, and K, right? So we're going to be putting the first vector, which is 1 minus 2, and then 2. You see 1 minus 2 and 2. Then the next one here, we're going to be putting 5, 8, and then 3. Now, if you can have the determinant of this matrix, you have successfully done A cross A plus A cross B plus C. So if you're given any vector, how to cross this, how to cross the two vectors, right? As simple as that. So how can I do this? From matrix 6, if you're picking this element over here, then you have to strike out these guys and take the determinant of this guy, right? So I'm going to have I into, take the determinant. Determinant is very simple. From the upper diagonal, you multiply, minus, then you multiply this other diagonal. So I have this multiplied by this. So let me write it. Minus 2 multiplied by 3. Then I have minus, then this guy multiplied by this guy. Then we have 8 multiplied by 2, right? Then similarly, we're now going to be going to the next one, right? So normally for matrix 6, this guy is positive, this guy is negative, 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 and that's how you continue doing. So for the J component, I'm going to take the component J with the negative, right? So if I do it properly, I'm going to take the determinant of this guy now, right? Taking the determinant, I will take out this guy, I don't need it. And I'm taking out this guy, which I don't need. So I will left with this, right? So let's clear everything. What was there actually? I think this guy is minus 2. This guy is 2. This guy is 5, right? So for the J guy, I'm going to do it because all we have now is 1, 2, 5, 3, right? That's what we're left with, 1, 2, 5, 3. For this guy, what we got was minus 2, 2, 8, 3. Then we take the determinant. So this guy, we have this and this. 1 multiplied by 3 minus 5 multiplied by 2. Then for the last guy, we're going to get K plus K. So what will be left, if we take out this guy and take out this guy, we'll be left with 1, 5, minus 2, and then 8, right? So we can take it, this and this. We have, by now you understood this and this. We're just going to get 8 minus then this and this, which is 5 multiplied by minus 2, right? So similarly, we are just going to multiply this minus 6. This guy is going to give us minus 16, right? Then for the J guy, we are getting 3 minus 10. Plus for the K guy, we're going to get 8. 8 minus should give us plus 10, right? So what we're going to be getting here is going to be minus 22i, this and this minus 22. For the J component, this and this should give us minus 7. So minus 7 multiplied by minus here, we are supposed to get plus 7j. Then what about this? We have plus 18 of K. So this become our cross product, right? So this becomes our A cross B vector plus C vector. Good. So this, how to solve this. So I think this is, before you know it, maybe you cannot try this by yourself. All you need to try now is, this is the method of proof. So you can prove that this we have just done now, it should be equal to when you do them individually. If you do A cross B, that's if you do A cross B, if you now add it with A cross C, if you do this individually, you should get this. That's what it means. So what I'm trying to say is that ijk of A cross B, this vector, will be that you take the determinant of what? A, which is 1 minus 2 and 2, then with B. Our B was what? 1, 3, 3. So we have 1, 3, and then minus 3. Good. If you take the determinant and then add it with A cross C, now A cross C should look like this. 1 minus 2 and 2, then C. Where is that vector C? Look at it over here. If you do it, 4, 5, and 6. So if you do this determinant, you get the value. Do this and get the value. Add them together, you should get this. As straight. Just you're going to get this automatically. So you can do this on your own. Put your answer in the comment section if it is true or not. Then this is called the distributive property in cross product, right? So this is the distributive property. So do it and tell me in the comment section if actually it is correct, or you can send it in the live classes when you are ready. Thank you. See you in the next video, and then also see you in the live classes. If you have any question, you can get across to me through any of our social media handle, especially the WhatsApp we have been using. Thank you.